Hello, Lovelace, and welcome to today's maths lesson, which continues our work on division, but this time involves numbers that don't divide nicely, and we're left with remainders. Okay, so we're going to carry on our work with 4-digit numbers, but this time there might be some numbers left over, some remainders. Okay, but first of all, a couple of little warm-up questions just to get our brains working. There we go, 3 questions today. Pause the video, have a go at those. Okay, the first one, 55 divided by 5. We should know through our tables. 5 lots of 11 make 55, so 55 divided by 5 is 11. For the second one, we're going to use that bit of information. We've got something divided by 5 is 1,100. Now you can see an 11 in that number and 2 zeros. So I think the missing number is going to be 55 with 2 zeros. Let's have a look. There you go. 5,500 divided by 5 is 1,100. And the final one, 550 divided by 50, a little bit tricky, but actually because we've got 2 zeros here, two on the same side of the equals, we could actually just ignore them just for a moment, because both numbers, 550 and 50, are 10 times bigger than 55 and 5. So if we just concentrate on the 55 and the 5, 55 divided by 5 is 11. We know that from that first question. So how many 50s would fit into 550? So 550 is 10 times bigger than 55. 50 is 10 times bigger than 5. So actually, because they're both 10 times bigger, they'll fit in the same number of times as this original question. So the answer is 11 again. You can fit 11 50s into 550. Right, Eva has got 13 straws and she wants to make them into triangles. How many triangles can she make? Well, the first thing you need to know is how many sides does a triangle have? And hopefully you all know it's 3. So we're dividing by 3 in this question. But let's have a look. Let's do it in a practical way. Let's actually build the triangle. So we're doing 13 divided by 3. There's 1, 2, 3, 4. Oh, and there's 1 left over. So we've got a remainder. Okay, so there's our answer. 3 goes into 13 4 times with 1 left over. Right, a couple of similar questions here. I'd like you to have a think. We've got Tommy, who's got 14 straws and wants to turn them into triangles. Dora's got 15 and Jack's got 16. All the children want to make triangles. How many can they make? Pause the video, have a think. Okay, well, let's start with Tommy. He's got 14 straws. So we're doing 14 divided by 3. There we go. He can make 4 triangles, but he's going to have 2 left over. So 4 remainder 2. What about Dora? She's got 15 straws. Now I've left 12 of them already set up as straws just to save time. So we've got 12 here, 13, 14, 15. We've got 15 altogether. And you can see that Dora can make another complete square. So 15 divided by 3 is 5. And finally, we've got Jack, who's got 16 straws. Again, I've left the 12 here already set up. And he's got 4 more onto that 12 to give him 16. And if we do that division sum, you can see he's got 5 completed triangles with 1 left over. So 5 remainder 1. Okay. And for the time being, that's all we need to do. If there's any leftovers, we just put R and the number for remainder. Now, with our knowledge of division, I want to ask you if these questions could possibly be correct. I don't want you to work them out. I want you to look at the question and the answer and decide, could it be correct? Or is it definitely a mistake? Take a minute, have a quick look. Right, well, let's look at the first one. 3,924 divided by 3 equals 1,307 remainder 3. Hopefully, you've all realized that this definitely can't be correct. And the reason for that is this remainder. We've got a remainder of 3 that's the same size as the divisor. We're dividing by 3 and we've got 3 left over. So that's not possible, because the 3 will fit into that remainder and we can just add another 1 onto our answer. So that is incorrect. You cannot have a remainder the same size as the number you're dividing by. What about this one? 3,242 divided by 4 is 810 remainder 2. Could that be correct? Yes, it could. And the reason is, if we look at the last 2 digits, the 10 and the 1s, we've got 42. And if we divide 42 by 4, then we're going to get 10 remainder 2. Okay? So just by looking at the last 2 digits, the 10s and the 1s, we can see that 4 goes into 40 10 times, and you'd have the 2 left over. So we would have a remainder of 2. So this one could be correct. We'd have to check the rest of the sum, but that one certainly could be correct with a remainder of 2. And what about this last one? 5,626 divided by 5. Could it be 1,124 remainder 6? Now, I hope right now you are screaming at your computer screens, no, it couldn't be. Of course it couldn't be, because our remainder is bigger than our divisor, than the number we're dividing by. And that's impossible. We can't have a remainder bigger than this number. Okay, so just a little way of doing a quick check after your calculations. If your remainders are the same or bigger than the number you're dividing by, then you've made a mistake and you need to go back and have another look. Right, now we're getting into our 4-digit numbers divided by 1 digit. Once again, I'm going to show it with the counters as well as the bus stop method, so you can see how it's working. But we're getting to the stage now where I'm happy to see the bus stop. You can say, use the counters if they help you, absolutely, and continue to use the counters if they help. But if you're becoming more confident with this, I would still like to see the bus stop method. I want to see this type of working. And I need to see your exchanges, guys, so I can see how you've worked it through. I'll explain that as we go. But if you just copy this and just put a number at the top, then I don't know how you've worked it out. I don't know if you've used the calculator, asked mum or dad. I don't know. But if you're showing your exchanges, then I'm confident that you know what you're doing. But I'll explain that as we go. So anyway, 5,291 divided by 4. Well, there we have it. There's 5,291. And we're dividing by 4. So we need to see how many groups of 4 we can get in each of these columns. Well, there's one group of 4 in the thousands. So what we're saying is 5 divided by 4 is 1. You can only get one group of 4 out of 5. But there's 1 left over. We can see there's 1,000 here. That's left over. So we're going to exchange that for 10 hundredths. And we show that here with a little 1 there. That's saying that one of the thousands has now been exchanged for 10 hundredths. So we've now got 12 hundredths. Okay, I need to be seeing these exchanges. If they're not there, I can't be sure you know what you're doing. So we've now got 12 hundredths divided by 4. So how many groups of 4 can we make here? 1, 2, 3. So 12 divided by 4 is 3. Move on to our tens. We've got 9 tens, and we're going to see how many groups of 4 we can make. 1, 2. So 2 goes in our answer, but we've got 1 left over. So this 10 is exchanged for 10 ones. There we go. And that's how we show it in the bus stop. So we've now got 10 ones that were exchanged from the 10 here. So 10 ones and 1 1. So we've got 11 ones. So 11 ones shared into fours will go 1, 2, just 2. So 11 divided by 4 is 2. And you can see we've got 3 left over. So that becomes R3, remainder 3. Okay? Hopefully that makes sense. So 1,322, remainder 3. Right, your turn. Pause the video. Have a go at these questions, please. Right, let's see. Please, again, make sure you are marking your answers and going back and making corrections if you have made an error. Right, we've got the counters here to help us work it through. So number 1, 3,938 divided by 3. We've got 3 groups of 300s, 1 group of 310s, 2 groups of 3 1s, and 2 leftovers. So altogether, 1,312, remainder 2, or R2. On B, 8,407 divided by 4, you should have got 2,101, remainder 3. There was 3 left over. Question 2. This is just using the bus stop, but don't be afraid of using the counters if it helps you. So how many 3s are there in 7,595? There are 2,531, remainder 2. And you can see the exchange there. I need to see that in your working, so I know you've understood. 8,567 divided by 4 is 2,141, remainder 3. 6,562 divided by 5 is 1,312, remainder 2. And 3,935 divided by 3 is 1,311, remainder 2. Well done if you've got those correct. Oops. Sorry. B, we're using greater than or less than. So you need to work out the 4 calculations. And if you've done that correctly, you will realize that 7,595 divided by 3 is greater than, that's a bigger answer than 8,567 divided by 4. And similarly, 6,562 divided by 5 is a bigger answer, is greater than 3,935 divided by 3. Okay. And then here we have the remainders. So we've got 3,513 divided by 4 gives you a remainder of 1. These 3 calculations give you a remainder of 2. These 2 give you a remainder of 3. And surprise, surprise, none of them give you a remainder of 4 because we're dividing by 4. So you shouldn't have a remainder of 4. Okay, so that's the reason. Because we're dividing by 4, there shouldn't be any remainders that big. Okay, our turtle friend says 5,627 divided by 5 is 1,126. Could it be right? No, absolutely not. He's not right. So have a think. Why is that incorrect? Well, it comes back to our times tables, guys. We know that the 5 times table, 5, 10, 15, 20, 25, 30, all the answers end in 0 or 5. And this is a whole number, and it doesn't end in 0 or 5. Okay? And because it doesn't end in a 0 or 5, we know that 5 will not go into it exactly. We're going to have a remainder. And in this case, we're going to have a remainder of 2. Because the 5 will go into 25, not 27, 25. And so there'll be 2 left over. And there's your final answer, 1,125, remainder 2. Right, we've got 349 people at a wedding. And they're sitting at tables in groups of 8. How many tables are we going to need? Well, first of all, we need to decide what the question is going to be. So we've got 349 into groups of 8. So we're going to do 349 divided by 8. So let's work it through. How many 8s are there in 3? Well, we can't do that. So we're going to put a 0 in our answer, but we've not used the 3 yet. So the 3 is going to be exchanged for 30 10, or for 3 10s. Okay, so we've now got 34 10s. So how many 8s are there in 34? Well, there are 4. 4 8s are 32. So that means we've got 2 left over. Our 2 10s are going to be exchanged and become 20 1s. So we've now got 29 1s. 8 into 29 goes 3 times with 5 left over. Okay, so we've got 43, remainder 5. How many tables are needed? We need 43 tables. Have a think about that calculation and that answer. Go back to the question. Do we need 43 tables? Well, if you were one of these people and you arrived at the wedding and you had nowhere to sit, you would not be very happy. Okay? People have traveled from all over the world to come to this wedding. People from Australia, people from America, people from China, Japan, the Philippines, from all over the world. They've traveled all this way and they have got nowhere to sit because you've only set out 43 tables. So actually, in this question, in this context, you're going to need an extra table. It might not be full. There's only going to be 5 people on it, but you still need the extra table. So it's really important, guys, that even if you do the maths correctly, you go back to the word problem and see if your answer makes sense. Okay? Time to pause the video again. Your final few questions. Have a go. All right, let's have a look. I know that if I divide these numbers by 5, the remainder will be 1. Is either correct? Well, we've just had a similar sort of question. We know that numbers divided by 5 end in 5 or 0. So if they end in 1 or 6, then they're going to have a remainder of 1. And all of these numbers end in 1 or 6. So either is spot on. Number 5. There are 459 children in a school, and they are sitting in tables of 7. Mo says they're going to need 65 tables. Does that sound correct? Okay. Well, no, Mo is incorrect. Because if we divide 45 by 7, then we are going to get, we're going to get 61. No, we're not. Sorry, I'm thinking out loud. We're going to get, we're going to get 65, but we're going to have some spare children. We're going to have children sitting on the floor. Okay, so 65 will not be enough. We're going to need 66 tables. One of them will not be quite full. So just like the wedding party, but we are going to need 65 tables. So no, we don't agree with Mo. Number 7, how many ways can you complete the calculation using all the digit cards so that there's a remainder of 1? Okay, how many have you come up with? Example I've got there for you just to show you how it's done. 325 divided by 4 gives us 81, remainder 1. Okay, but are there any others? Can you find any more combinations? And do you notice anything about it? And Dora is thinking of a number between 500 and 600. When she divides it by a 1-digit number, it has a remainder of 4. What could Dora's number be? Now, there's quite a few answers to that one. So I'm not going to list them all, but let's see if you can solve that problem. Okay. That is the end of today's lesson. Well done. Please remember to mark it. Correct any mistakes you've made. Make sure you understand where your mistakes are. Remember, you can always go back and look at sections of this video or previous videos just to reinforce your understanding. Okay, take care, guys. Take care of those around you, and I will see you all very soon.